Hello, we are Group 25, presenting Phase 2 of our Notes Management System project for CSE 412. I'm Brandon Lim, and with me today are Sahil Pai, Sahir Khan, and Sarish Tiwari. And today we'll walk you through the complete Postgres database implementation, which covers our schema design, data population, and application queries that demonstrate all of our CRUD operations. And let's start by looking at our data structure. So here is our ER diagram from Phase 1, now in the database itself. So we have our 5 different tables as well. So you have our users, notes, tags, user stats, and note tags. They're all established in our notes management database in Postgres. So I'll be going over users and notes right now. So we have user properties right here. Go to columns. We have 5 columns. So we have a user ID, which is a primary key, which is already always established for every user that's created. And we have our name, email, and password, which are not null. So it needs to have a value for every user, or else the user cannot be created. So they have various lengths: 150 for name, 255 for email, and the same for password. And we also have created timestamp, which just defaults to now. So whenever the user creates their user, it'll also have a created at timestamp alongside it. So we have our checks here as well for users. So we have the email check, which has our format. So it's at something not something. So it'll always have that. So the email is actually an email, and the unique check as well. Unique key as well, which for the email. So there cannot be a duplicate email, unlike name or password or anything like that. That's fine, but the email has to be independent from every other entry. So we have that here. Primary key is the user ID, as you can see here. So we have our notes next. So we go to properties here. You have 7 columns. So note ID, kind of adjacent to user ID. So user ID has a user ID. Sorry, user has a user ID for every user. Notes ID has a note ID for every note. And we have title here, which has to be not null. So thing has to have a title. And we have a content column here, and it's not null. So you can leave it blank. You can come back to it later. That's the whole point of the notes content. And we have created at and last modified timestamps as well, which just default to whenever the user enacts this certain action. And we have our status here, which defaults to active, but we'll have some more that I'll explain later. And user ID, which is adjacent from our users tab up here. So we have our constraints here, which go to checks here. It'll just check if there is a value for title. The status is active or archived or pinned. So one of the 3. And the dates check, so last modified, has to be after the created date. So just to clear up any confusion as well. And we have our foreign key, which is very important. As I mentioned, it cascades from the users table. So all of the users of the notes data that is associated with a user ID will be deleted when the user itself is deleted. So anything that happens with the user, if it's deleted or created, the notes will also have their effect. So that was the first 2 tables of our database. And I will now let Sahil go over the data population as well as the rest of the tables.
Thanks, Brandon. Let me now show off the remaining tables. So first, let's start with tags. Let me run that here. The tags table stores our tag definitions. Tag ID, as you can see here, is the primary key. Tag name, that dictates essentially like what we want to name our tag, and it has to be unique. The color field here, that stores the hex value for the color codes, and also the created at is just a timestamp for when that was created. And essentially, we have check constraints assuring tag names are also 2 or more characters long, and obviously the colors have to match the hex format. That's just validation. Now let me show you the next table, which is note tags. Um, as you can see here, it's practically the same thing, but it's our junction table implementing the many-to-many relationships between notes and tags. So it has the foreign keys to both notes and tags, which both with cascade delete, and unique constraints on the note ID and the tag ID, which prevents assigning the same tag to a note twice overall. And let me also show you user stats. The user stats table has a one-to-one relationship with users. The user ID is both the primary and foreign key, and it tracks total notes and total active tags with check constraints, ensuring they cannot be negative. So let's now look at some populated data here. I'm going to show you this one over here. Okay, cool. So if I run that, essentially you can see the results here, and what it shows is your note ID with the title. For example, this is like the project meeting notes. This is what the user would have entered, and then the content, so essentially what they typed. And then you can also see other things like the status, the created date, and the last modified, all of which are very important for keeping track of specific note metadata. I can also show you one more here, which is another SQL command for our database. And as you can see here, this essentially comes out, gives you the tag ID with the name, and then the color, and then the timestamp, which is how you would essentially keep track of that color for the tag that was assigned. Um, and overall, You can see how these show the many-to-many and one-to-one relationships depending on the table, and how these tags can be applied to multiple notes, which is very important. And also, I also did want to touch on the data here. The data is generated using Python. I wrote a Python script to come up with a bunch of metadata that I was able to fill into tables, and we use the schema up here over here. We use the schema here. You'll see it all along here for each of the tables. And that schema was how we dictated exactly what the tables would look like in terms of metadata. So that way you don't have extra fields that aren't already defined.
Thank you, Sahil. My name is Sahir Khan, and I'm going to continue with the SQL queries. So I'm going to show four SQL operations, which are insert, update, and two delete queries, which are all going to be inside pgadmin. So first, let's start with the insert query. So this query is going to be creating a brand new note in the database. And as you can see right here, I'm going to paste it over. So the title of it is going to be Costco shopping list, and the contents is going to be eggs and bread and coffee and oranges and milk. And I'm setting the status to active and also both the timestamps of created date and last modified. Those are both going to be to the current time with the now function. And so we're going to run the execute script. And as you can see, it says query returned successfully. So now if we just run a quick select statement to just check if our insert operation worked. So as you can see, if we run this, then we scroll to the very bottom. Right here, you can see Costco shopping list, eggs and bread, and coffee and oranges and milk. So that's that. The next one is the update query. Now the update query is just going to be changing a pre-existing note, which is going to be the specific note that has the note ID of 3. And what it's going to do is just that it's going to update the status from whatever it is to now being archived. And it's going to also update the last modified timestamp to the current time. And so now if we run it, then you'll see query returned successfully. And if we also just now run a secondary select statement to check if it worked, then you'll see right here. So yeah, this is the specific note ID with 3, and you can see that its status is now archived. So that means that it worked. And now if we move on to the delete, so the first delete is just going to be completely removing a note. And that specific note is going to have the note ID of 5. And what this is going to do is just because there's a cascade delete constraint set up, that means that any related entries in the note tags table that references this note will automatically be deleted as well. So now if we execute it, and you can see query returned successfully. And now if we run a secondary select statement to check if it worked, then you can see right here, select execute script, and nothing shows up. And so nothing showed up for that note ID, which means that it's all gone along with its linked records. And now if we move on to the last delete statement, this isn't going to completely remove a note, but it's just going to remove the relationship between the note and the tag. And so if we run it, you can see that it returned successfully. And what that did is that it just deleted the connection between a note with ID 3 and a tag with ID 5 from the note tags junction table. And so it basically just unlinked the note from the tag, but both are still in the database. And so now if I run a secondary select statement to check if it worked, then as you can see right here, select run, then you can see that again, nothing popped up, no results for that specific note tag pair, which means that the relationship was deleted, but the data integrity was still kept. And so that's it. Each query did modify the database, and the select statements after showed that each change worked. And so now I'm going to pass it on to Suresh, who will wrap up.
Thanks, Ahir. My name is Sarish Tiwari, and I'm going to be going over how we populated our data to these tables. So we have our 5 tables here. We basically used a Python script, and we used our DDL as a schema to ensure what attributes we needed for each table as a guide. And then we used a Python script to then generate a bunch of synthetic data for all attributes for each table, for our 5 tables here. And I'm gonna go over all of our tables. So first we have our notes table. As you can see, we have our note ID title, what goes in the text of the note, 2 timestamps when they were created and last modified, and of course the status, and of course the user ID it's connected to. But we also have our tags, including tag name, the hex color, and a timestamp for them. We have our users, a list of all of our users, where we have our user ID, name, email, password, and created. Password, of course, is encrypted, and all of this was generated, of course. And then we have a user stats, which acts as a statistical dashboard with a bunch of fun little stats like total nodes, total active tags, and last login date for all users to kind of get, general information about their account. And of course, we also have node tags, but I dropped all the values in here because I wanted to show you the import process. So I'll show you our node tag CSV, which we generated with a bunch of synthetic data, which this contains all the relationship between our node ID and tag ID, because they need to be connected to each other so that if one is deleted, the other gets deleted, because it cascades. So we're going to go into our node tag, and I've already selected the node tag CSV files you can see here. And we have the header turned on because we wanted to ignore the first row of our of our um, of our CSV file because it contains all the column names and not the actual data we want to import. And of course, our delimiter is set to the comma. We're going to import it. And as you can see, the process has been completed. So I'm going to refresh this. And as you can see, all of our data was cleanly imported, 151 rows. And we have our no tag ID, no ID, tag ID, and of course, the assigned date. And it's branching from all the other tables, from the notes table and the tag table. So yeah, and these are all the constraints that were imported as well. And yeah, so thank you very much for listening. And this is our note-taking application and our setup data and our database setup with it. So thank you very much for listening and have a great day.